Let's examine the randomization test features in the OM software for the ordinal analysis crossed orderings procedure. Now we can turn on the randomization test by selecting this box. We can also save the results from the test by selecting this box here, Save Randomization Results. Now the number of trials is set to 1,000 by default. I'd recommend if you have a large data set, let's say 10,000, 100,000 cases, you might want to bump that down to 10 or 100 just to see how long it's going to take to iterate through. Now with 1,000 iterations here and 1,000 trials, we're not going to have any trouble getting through those with only 15 observations total. Now you'll always be given the chance to interrupt the process if it's taking a long time. This stop button will become active and you can select that to interrupt it. Now we can also see that we have an all observations option for randomizing, or we can randomize by the deep structures. The all observations is the default, and let's look at that first. Now with this option, what's going to happen is that the software is going to randomly shuffle the first ordering observation. So here the first ordering is the time, the seconds, and here we see it over here in the data spreadsheet. So this column of numbers is going to be randomly shuffled. So this 6, for example, can end up in the 2nd, 3rd, 5th, 10th row. The 12 can end up in the 1st row or somewhere else. So all of the values are going to be shuffled into a new set, essentially. And then the algorithm is going to go through and compute the PCC index for those randomized data. It'll set that PCC index aside. Then it will randomly shuffle the data again, compute the PCC, and set it aside. Now we'll do that 1,000 times. And then we're going to use that information to see how easy or difficult it is to randomly shuffle the data and obtain a PCC equal to or greater than the one that we have for the actual data that we see on the screen here. So recall, we have the experimental and control groups here. We have the reaction times, and our prediction is that the control individuals will have higher scores or reaction times than the experimental individuals. So let's go ahead, and we've got the options selected here. I'm going to go ahead and turn off the pairwise results. That's really redundant. We only have 2 groups here, and so we'll go ahead and select OK. It quickly iterates through, and we see our ordinal prediction here, and then we see 56 possible pairs there between the control and experimental. 49 of those match the ordinal expectation, PCC of 87.5. Then we get the randomization results here. I'm going to just hit enter a couple times here so I can scroll that up. So the PCC value is reported again, 87.5. Here are the 1,000 trials that we set. Now for this example, or this run of 1,000 trials, the lowest PCC was 7.14. The maximum PCC was 98.21. Now 7 out of 1,000 times, we found a PCC of 87.5 or higher. So notice here, values greater than or equal to observed % correct. So 7 times out of 1,000, we found PCCs of 87.5 or higher. If it takes 7 divided by 1,000, that's going to give you 0.007. You round that to 2 decimals here, and it's 0.01. So that is your model C value or chance value. So what that tells us then is if we just randomly shuffle the data, it's difficult to find a PCC of at least 87.50. We only see it 7 times in 1,000. So if we have 2 ways of interpreting that 87.50, is that due to our causal understanding behind the study, or is it due to just physical chance, dumb luck in a way? Well, here it looks like the causal explanation is better, because it's difficult to just randomly shuffle the data, dumb luck, chance, and get a PCC of at least 87.50. So this gives us confidence that the data need to be interpreted in terms of cause and effect rather than in terms of chance or physical chance. Now let's go to the data edit window, and we can see the saved results. So I'm going to actually go ahead and look at the define orderings window. Let's just go ahead and magnify this. Let's stretch a few things out here so we can see all of the labels. And let's turn on the distribution. So the correctly classified pairs of observations, the classifiable pairs of observations, that was always 56 since we didn't have any missing data. And here are the PCCs from those 1,000 randomized versions of the data. And here we see that smallest value was 7.14. The largest value was 98.21 that we saw before. And here we get a normal looking distribution of PCCs. Now it doesn't have to be normally distributed in the OM software. We don't make any assumptions about normality. homogeneity of variances or anything like that. But here we do have a somewhat normal looking distribution of PCCs. And we can also see that there are the 3, 4, 5, 6, 7 values that were 87.5 or higher. But you can also see then the vast majority of the PCCs were lower than 87.5. So it's difficult to just randomly shuffle the data and obtain a value that high. So this analysis allows us to choose between interpreting our data in terms of cause and effect or interpreting it in terms of physical chance. And given the low C value that we obtained from our randomization test, 0.01, probably a good idea to go with the cause and effect interpretation of these data.